Alright, so this week we are going to be reviewing some exponent laws. Right, let's zoom in a little bit to make it bigger. Exponent laws. And okay, so before we start the actual laws, let's review what an exponent is. So say I have something like a to the power of b. And what this means is that is a times a times a times a b times. So this is, we're multiplying a by itself b times, and this together is called a power. And this is called the base, and that is the exponents. Okay, now that we got that out of the way, let's get into the laws. Okay, so the first thing we're going to do is the sum law, sum rule, or whichever words. So let's start with an example, and we're going to have something like x to the a times x to the b. Now, what is this gonna give us? Okay, well, let's write it out, right? Actually, we're going to assign some values. So we're gonna let a equal 1. Actually, okay, I got it here. I got it better already. We're going to erase, and we're going to raise this to 2 and 3. So x squared times x cubed. So what is this going to give us? Well, what we could do is we're going to expand this entire thing out. So this is 2 and this is 3. Okay. Now, what do we do here? Well, now we can clearly see that this is x multiplied by itself 5 times, so therefore this is x to the 5. In other words, 2 plus 3. So therefore, we will establish the following. So therefore, we have x to the n times x to the m. This implies that this is equal to x to the n plus m. And this is the sum rule where we add the exponents. Now we're going to do the subtraction rule. So say we had something like let's write x to the 5 over x cubed. What is this going to give us? Well, we're going to do what we did here and expand out the x. So this is going to give us x times x times x times x times x. And at the bottom we have x times x times x. Now we see a nice cancellation on the top and the bottom, and we are left with let's use a different color, and we are left with x squared. And you'll notice that it's actually equal to x to the 5 minus 3. So we're subtracting. Okay, so therefore we can conclude that x to the m over x to the n, that is equal to x to the n minus n. Okay, now we will take a look at negative exponents. So negative exponents. That's weird. Okay, negative exponents. So what do we have? Well, say we had something like, okay, so first we're gonna start with x. We're gonna start with x to the n, and what we're going to do is we're gonna divide by x to the n plus m, where m is greater than 0. Actually, we don't need that. Okay, so what is this going to give us? Well, based on the subtraction rule, we can subtract these. So we get that x to the power of n minus n plus m, and that is going to give us x to the minus m, because we distribute. Oh, you should probably know that already. So, and then on the right hand and on the left hand side, we can actually break this up using the sum rule we just established. So this is going to be x to the n over x to the n. And this is another way of writing this is x to the m, x to the n, x to the m. So x to the m equals x to the minus n. Okay, well, we see a nice cancellation of the top and bottom x to the n, and therefore we are left with 1 over x to the m equals x to the minus n, and this is the negative exponent law. So, okay, now I want to move to power. So first, let's think about this. So we're going to consider a binomial raised to a power. So let's example, we're gonna take 2xy to the nth power. Well, actually, let's take it to the third power. What is this gonna give us? Well, we know that this expands to 2x to 2xy times itself 3 times. And we can actually rearrange this. And you'll notice that this is 2 times 2 times x times x times x, y times y times y. Oh, this is another 2 here. And we can see that this is now equal to 2 cubed times x cubed times y cubed. And you'll notice that we actually sort of distributed the power to each term right here. So in general, we can say that let's have another to the nth power. That's equal to x to the n, y to the n. Okay, now we're going to consider a quotient raised to a power. So let's consider this. we're going to consider something like x over y to the 5. How will we simplify this? Well, we can first rewrite the y. We can distribute, okay, well, we're going to first rewrite the power of y as y to the minus 1. And this is going to be raised to the 5. Now we can just use the rule we used here, right? So this is going to be x to the 5 times y to the minus 1 raised to the 5. Now we haven't learned how to simplify this yet, so we're going to do that first. So say we have something like x cubed raised to the 2. How will we simplify it? Well, let's think about this, right? Let's expand out the x cubed, and we're multiplying it by. And using the sum rule, we can conclude that this is equal to x to the 3 plus 3. In other words, x 3 times 2, which is equal to x to the 6. And you notice that the 2 and the 2 here are the same. So therefore, we can conclude that x to the n to the raised to another power. Remember, this only works when there's a brackets. Otherwise, the rules are different. This is actually equal to x to the n. And you notice that we just multiplied these powers right over here. So this is the rule we just used. And now we can go back to this equation. So this is going to be x to the 5, y to the minus 5. And now we can actually complete this rule. This we can now rewrite as using 1 over x to the m equals x to the minus m. We can rewrite this as x to the 5 over y to the 5. And you notice that, again, the power also distributes to the denominator and the numerator. And these are basically all the rules.